We're going to use the second derivative test to find local extreme values. So to find local extreme values, it's always the same thing. We need to find our critical point. So that's the first step. I always have to find my critical points. And my critical points occur when this derivative is equal to 0 or the derivative does not exist. So no matter which test I use, I always have to find my critical points. So what I'm going to do is I'm going to find the derivative. So notice that I have a product. So I'm going to let u be sine of x. So v is going to be cosine of x. The derivative of u is cosine of x. The derivative of v is going to be negative sine of x. So my derivative is going to be the derivative of u times, let's try that again, the derivative of u times v plus the derivative of v times u. And it has a minus sign because of the negative. I just went ahead and multiplied them together. The negative sign times sine is just negative sine times sine of x. So cosine times cosine is just going to be cosine squared x minus sine squared x. So there's my derivative. I'm going to set that equal to 0, and I'm going to need to solve this. So I'm going to go ahead and move the sine squared to the other side, and I'm going to take the square root. So cosine of x is going to equal plus or minus, because whenever you take the square root of both sides, you get a plus or minus. So cosine of x equals plus or minus sine of x. So what this means is I want my coordinate where both sine and cosine are exactly the same thing, whether it's positive or negative. So they can also be opposite sign. Well, there's only one on the unit circle, there's only one coordinate where both numbers are exactly the same. And that's going to occur at pi over 4. That's the square root of 2 over 2 and the square root of 2 over 2. But because it's plus or minus, what that means is it doesn't matter if they're opposite signs as long as they're the same. So it's also going to occur at the other coordinate. So if you're still not sure how to do the unit circle, remember that this is 1 out of 4, this is 2 out of 4, so this is going to be 3 out of 4. This is going to be 3 pi over 4. The other one's going to be, they're both going to be negative, so they're both going to be the same. So this is going to be, since this is 3 out of 4, this is 4 out of 4, so this has to be 5 out of 4. And then the last one is going to be a positive and a negative. So 5 out of 4, 6 out of 4, so this one's 7 out of 4. Or you could have also done negative pi over 4 for 7 pi over 4. Okay, so there's actually 4 critical points. So x is going to be pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So now, usually what I would do is the first derivative test says I'm going to check on a number line and check the sign to the left and to the right of these points to see whether my derivative is increasing or decreasing. That is the first derivative test. The second derivative test says I'm going to find the second derivative. So my second derivative is going to be, I'm going to have to use the chain rule since my first derivative is cosine squared x minus sine squared x. I'm going to use the chain rule because this is the same thing as cosine x squared. So I'm going to have 2 cosine x, everything on the inside stays the same, subtract 1, times the derivative of the inside. Same thing for my second one, it's going to be minus 2 sine of x times the derivative of the inside. So I'm going to have negative 2 cosine of x sine of x, and I'm just going to rearrange this term to be 2 cosine of x sine of x. So notice they're exactly the same term, so I'm just going to add them together. So my second derivative would be negative 4 cosine of x sine of x. So I'm going to use this as my second derivative test. So what I'm going to do is I'm going to substitute each of my critical points into my second derivative. So I'm going to start with pi over 4. So I'm going to have negative 4 times of pi over, cosine of pi over 4 sine of pi over 4. Well, this is going to be negative 4 times the square root of 2 over 2 times the square root of 2 over 2. So this is going to give me a negative number. Because it's a negative number, that means it's going, at this point it is concave down. So that means that this is going to be a local max. So that is where the local max occurs, at pi over 4. Okay, so let me check 3 pi over 4. So I'm going to have negative 4 cosine of 3 pi over 4 sine of pi over 4. So cosine of 3 pi over 4 is going to be negative 1/2, and sine of 3 pi over 4 is going to be positive square root of 2 over 2. Sorry, I said negative 1/2, but it's the negative square root of 2 over 2 and square root of 2 over 2. So I'm going to have negative times negative square root of 2 over 2 times the positive square root of 2 over 2. So this is going to give me a positive number. So what that means is that at pi over 4, this is concave up. Because it's concave up, that means I have a minimum. So this is where my minimum value occurs. Remember, this is we're just checking the x values. We just want to know where they occur, not what the extreme values are. So we have where a local max occurs, and we also have where a local min occurs. So I'm going to check the last 2 points. The next one's going to be when x is 5 pi over 4. So I'm going to have negative 4 cosine of 5 pi over 4 times sine of 5 pi over 4. So this is going to be negative 4 negative square root of 2 over 2 times negative square root of 2 over 2. So I'm using these points right here, where they're both negatives. So this is going to give me a negative number. So that means that this is concave down. So that's going to give me a local max. So this is where my local max occurs. Okay, and then the last point is going to be 7 pi over 4. So I'm going to have negative 4 cosine of 7 pi over 4 sine of 7 pi over 4. So that's going to be negative 4 times positive square root of 2 over 2 times negative square root of 2 over 2. So that's going to give me a positive. So because it's a positive, that means that it's concave up. So this is where the local min occurs. So this is the local min. Okay, so I have 2 local mins and 2 local